Quadratic inequalities. I'm Anil Kumar, and in this video we are going to discuss some concepts which will help us to solve quadratic inequalities. So we have taken a very simple example here, which is x squared is greater than or equal to 6 minus x. Normal approach is bring all the terms to the left side, then you get 0 on the right side. Let's do the normal approach and solve this inequality. So we get x squared minus x becomes plus x, and then we have minus 6, and it is greater than or equal to 0, right? So now we have quadratic equation on the left side and 0 on the right side. The whole idea is once we have 0 on the right side and we need greater than or equal to, that means part of solution is the zeros and wherever this graph or the parabola is positive, right? So that way it becomes very easy for us to write down the solution. Now to find the zeros, let us factor it. We are looking for two numbers whose product is minus 6 and sum is plus 1. So numbers are 3 times 2 is 6. Minus means one of them is positive, one of them is negative. Bigger number is positive. So 3 is positive. So we get x plus 3 times x minus 2 is greater than or equal to 0. So with this statement, we now know what are the zeros, correct? So the zeros are at x equals to minus 3 and at x equals to 2. So these are our zeros. So we got zeros with this, right? Now these zeros, let me plot these zeros on the x-axis. One is at minus 3, right? Now since we are looking for greater than or equal to 0, I'll make it a solid bullet here, right? And at 2. So these are the two zeros. Now if you look into the equation, it says greater than or equal to 0, right? Now couple of things which you can do from here. One is you can graph. Now graph is kind of easy at this stage since we know the zeros and we know this parabola has got leading coefficient as positive, so it will move upright. So if I have a graph which is opening upwards, so it will be kind of, let me just sketch a rough graph here. So I don't know the exact values. What I'll do is I will just go with some dotted line, right? But the idea is to just complete the graph and know how it should look like, right? So that is the kind of parabola. We are not exactly interested in these exact values, but we know kind of that it goes through the zeros and opens upwards. And we are sure about one thing, that between these two zeros the graph is less than 0, right? But beyond these two values it is positive. Do you see that? And that is what we want. What we are looking for is a sign which is greater than or equal to 0. That means the solution is from minus infinity to this point, which is minus 3, right? But minus 3 is included since it is greater than or equal to, right? And the other combination we say union, right? From 2 is included to infinity, which you can never reach, and so which will never be included, right? So we get our solution at this stage from the graph. Perfect, right? So that's one way, and we have got a couple of videos in which we are discussing this strategy. Now the next strategy which we discuss is intervals. As you can see that these two zeros are dividing our plane into 3 intervals, right? So these are the intervals. If you like, we'll just work on the same graph. So these are the intervals, and so we have one interval which is from minus infinity to minus 3. The other one is between the two zeros, which is from minus 3 to 2, right? And the third one is from 2 to infinity. So we have these 3 intervals, and what we do in this is we take test points. So let me just do that method also here so that we summarize all the activities at one place. Now all the methods which we have been discussing about. So from here we know the zeros are at minus 3 and 2. So I'm writing my zeros at minus 3 and this one is at 2. Okay, now since it is greater than equal to 0, I'm making solid bullets here. These points are included in our solution, right? Now what we do here really is we just take test points in these intervals. So the test points in the intervals could be selected as minus 4, between them 2 and 3 here, correct? So these are our test points and we'll just test our function whether it is positive or negative, correct? Now another way to look into it is that you need greater than 0. That means either both should be negative or both should be positive, right? So those forms the solution set for us. That is one way of looking into it. The third way is you just plug in minus 4 here, right? So if I write minus 4 here, in that case this becomes negative, right? And this is also negative. So their product is going to be positive. So what I have here is, let me write down these two factors, which are x plus 3 times x minus 2, right? Now if I plug minus 2 or substitute minus 4, when I substitute minus 4 into my quadratic equation, I get this as negative, right? And this also negative. So basically it is negative times negative, which will give me positive. Do you see that? If I plug in 0 here, then this is positive, right? The first factor is positive, the second factor is negative. So that will give me a negative answer. Do you see that? If I plug in 3, then 3 plus 3, that gives me a positive first factor, and this is also positive factor. So what I get is also positive. Do you see that? Now when I'm saying greater than equal to 0, we are actually interested in positive values, right? So wherever we get positive values, that forms the solution set. And these intervals are, as you can see, from minus infinity to minus 3, right? And from 2 to positive infinity, correct? So this zeros split the whole domain into 3 intervals, and testing these intervals straight away gives us the solution, and that is the interval method which we had been discussing about. Finally, we can write down our answer using any of these methods, and the answer is that x belongs to real numbers where x is greater than equal to minus 3 and less than equal to 2, right? So these are all the methods which we have discussed so far. Now what I want to bring to your notice is that we could have actually another method, right? And that is that we could actually see our function, or we could actually see our inequality x squared greater than equal to 6 minus x as a combination of 2. That is, parabola x squared is greater than equal to the line 6 minus x or minus x plus 6, right? So what I have done here is, on a graph we have plotted a parabola which is x squared, right? So this is x squared for us, and then we have a line here which is, I should write minus x, okay, minus x plus 6, okay. So that becomes this line, right, going downwards with y-intercept at 6. When we say that x squared is greater than equal to 6 minus x, that means this part of the parabola should be above the line, right? So that means this is the point where they intersect. So let me highlight these points. And as you can see from here, that the part of solution is when the parabola x squared is, the value of parabola x squared is more than the line, right? In between, we know parabola is down, right? It's not greater than equal to, right? But beyond these points, like here, you can clearly see that the value x squared is more than the line 6 minus x, right? Similarly, on the left side from minus infinity to this point, you see the parabola is rising much faster than the line, correct? So that becomes the part of solution. Points of intersection are same, which is minus 3 and 2. So from the graph, we can read these 2 points. And since the inequality is greater than equal to, we need to include these 2 points and extend towards the infinity, minus on one side and plus to the other side, and we get the same solution. So that gives you a great concept of looking into quadratic inequalities as a combination of quadratic function and a linear function. I hope you appreciate this method, and that brings me back to the whole thing, bringing everything together, and I hope this whole picture of quadratic inequalities brings a new appreciation for the topic. And I hope you enjoyed these set of videos as much as I enjoyed making them. Thank you and all the best.